Hello interwebs, welcome to Let's Fix Computers. I've got a MacBook Pro here. This is an A2159 and it does not switch on. So let's take a look at this thing and see if we can find out why. I'm going to start out just by plugging in a Type-C connector and we'll just see what kind of response we get from the power supply. So I'll plug that guy in and it looks like we're stuck at 5 volts and we've got 18 milliamps. So it's not doing a lot. It's not negotiating 20 volts. So that means there's some kind of problem with the main power input there. It doesn't look like it's doing any kind of cycling. There's no jumps in the graph or anything. So not a huge amount of information there. Let's take the cover off and have a look inside. So let's start by getting the screws out the back and doing a visual inspection on the inside to see if we can spot anything. According to the customer, it was fine and then it wasn't. So there's no reported issues, like a liquid spill or anything like that. But that doesn't necessarily mean that we're not going to find anything like that, because sometimes you can get like humidity damage and stuff like that, where you get something that does the same thing as liquid damage, but just because it's been in a humid environment, like someone walks through the rain with it from the car back to the house or something like that. So let's pop this back cover up. This thing's pretty clean on the inside. There's honest dust marks there. There's no tide marks. So this board is an 820-01598. So I'm going to bring up the board view for it using Flex Board View here. And I'm going to have a look at the main power rail first. So let's find PPBus G3 Hot on this. Say the line, Bart. Because that's where we want to check if we're shorted just straight off the bat. Right, so F6700 there, that's our main fuse. This board upside down, yes, let's just rotate this. So it's the same way up as how I'm looking at it. Alright, and it's down the bottom there. Oh, F6700 is no stuff, that's fun. F7000 in that case. Okay, so F7000 is down here. I'll give you guys a closer look when we actually get to the more detailed stuff. I'm just going to buzz this fuse out first, so let's see what we get. Oh, hey, look at that. Yeah, we got a short on PPBus G3 Hot. Fun stuff. And the fuse has not blown by the looks of things. Let's just check both sides. And the fuse is intact. Okay, we're going to get the board out of this and then we'll get it under the microscope and take a closer look at it. Let's start stripping. Okay, so PPBus G3 Hot, the infamous PPBus, is the main power rail in a MacBook. And if there is a short circuit on that power rail, usually that means you've got a simple problem here. There's probably a bad capacitor somewhere on this board. It's not a sure thing, but PPBus shorts are usually going to be something that is approachable by a mere mortal. So I'm feeling pretty good about this. So there being a short on that rail is the reason why the charger was only going to 5 volts. The USB Type-C connectors go to a interface chip, which handles the USB Type-C power delivery, power negotiation. And those chips are detecting that their output is shorted, so they're not switching up to a high power state. I would have expected to see some kind of pulsing when we checked the when we plugged the charger in at the beginning of this. I would have expected to see something there that would indicate this, because you would usually see some kind of rhythmic sign or a wobble or something like that, showing an attempt to switch on and off. But yeah, we didn't see that. It's not a given though, so I guess not. I have a suspicion this thing has been taken apart before, but I'm not certain. There was a screw missing there, and some of these bits are coming off fairly easily. So, but then it was super clean inside as well. So I don't know. No idea if we're gonna see any past damage. That's our battery disconnected. I should have done that first of all. And I think we're ready to come out. Let's have a feel. That's lifting, that's lifting. Up we go. Just need to wiggle it around. Pop that display connector off. Yeah, that was holding me up. There we go. And we're out. I'm just having a quick look around. Where we had that missing screw, I'm just looking around just to see if there's actually just a loose screw in here. No, it doesn't seem to be that way. Right, looking at the back of the board, I'm just going to look for any craters, any screaming signs of distress. Not seeing anything. So it looks like we're not going to get a lot of help visually speaking. And already my brain is going to inject power. But there's a couple of areas of the board that I'm going to look at first, just in case. One of the big hot spots is we want to check the NAND power rails, because the NAND power rails, so that power the built-in SSD chips, which I think are these guys on this board. Those are prone to failure. I don't know if it's on this particular board. I just know on the modern MacBooks they're always check those. So we're going to have a look at those. I've got to find them first because I don't know where they are on this board. So let's just try searching for NAND. Is that a thing? Oops, not AND. NAND. iSense SSD NAND PNN. 2.5 volt NAND. That's the kind of thing I'm looking for. There we go, that looks promising. That's a power supply into NAND chips. So let's bring in the microscope and take a closer look. So first things first, let's just have a look over here. Here is the PP-Bus G3 hot input fuse that I measured before we started. So that's what that looks like. I'll put my black probe on this screw hole and we'll just check that fuse. And as you can see, we've got a pretty good short there. You know, that's 0.6 ohms or so. Can I go lower than that? Yeah. Like when I get a short to ground, I want to see like 0.2, 0.3 ohms, a really deep, like almost as low as you can go, just what's in the probing kind of thing. You know, we're sitting at sort of 0.6, 0.7. There's stuff that could be, but I'm not going to jump to conclusions yet. So if we pan down a bit, there's one of the NAND chips. The other one is on the other side, and we've got a vacant spot where there would be more if this was a higher capacity motherboard. And there we've got the power supply for the NAND chips. So I want to check these guys. So the output, side of it is the top of these two big inductors here. So I'm just going to check if that is shorted. So once again, I'm going to put my black probe on a screw hole, and we're just going to check these pads here. Right, 3.5 kilo ohms, good times. Cool. So there's no short circuit on this. So it's not the power rail for the NAND chips, which is all good. What about these capacitors here? Is there anything going on there? Right, that's shorted. What about the other side? Yeah, these capacitors are... What about that one? Yeah, same. these capacitors are shorted. However, these might be input capacitors, and we might have PP bus G3 hot coming in here. We can easily test this just by looking at the board view. So that's these guys. Yeah, that's PP bus G3 hot. So we're expecting these to be shorted because that whole rail is shorted. So that doesn't necessarily mean these capacitors are at fault. However, they are on the faulty line. Let's take this opportunity just to do a quick tour of the board and just look for suspicious capacitors, because you get lucky more often than not. Again, those capacitors don't look great. You know, you could very easily believe that they've got marks on them, but whoop. I think that's fine. I think I'm going to go for the injection. I think I'm going to do it. Right, before we do it, I'm going to quickly download notes for this board. So let's go to the board preferences, and I'm just going to see if there's any tips that I can get for this. So through the miracle of Flex Board View, we now have notes and solutions for this board. Right, we've got the boot sequence and stuff. SSD power rails and stuff like that. Yeah, full boot sequence, that's very nice. However, we are falling over at step 1 of this. Step 1, PP bus. So we don't have this. So yeah. Okay, fine. I'm going to inject. I'm going to quickly grab the Type-C connectors out of the chassis and plug those in. And I'm going to point my thermal camera at it and just see if there's anything lights up. Now, I don't think my thermal camera is quick enough to pick up this kind of thing. Paul Daniels has got a really slick setup that pops things out for him. I don't think I'm going to catch anything other than reflections here, but it's worth a try just before we start injecting power. Lots of people like to just go straight for voltage injection the moment they find a short circuit. But voltage injection should always be the last step of your diagnosis, not the first, because it is by nature a rather violent way of fault finding. Right, now I'm getting just a whole load of reflections. Nothing that actually... No, there's nothing peering there. There's not enough power going through the system. We've got 18 milliamps, that's nothing. Okay, that's fine. Let's gear up for injection. Right, I think I might have been paused just then. So I've just soldered 2 jumper wires onto the board. I've put one of them onto the vacant fuse pad, so that's directly onto PP bus G3 hot, and the other is onto the ground side of this massive capacitor here. So we have 2 jumper wires with a short circuit between them. And I'm now just going to set up my power supply for injection. We're going to start at 1 volt and 2 amps. I'm expecting to have to go a little bit higher than that because you usually do. And I'm going to put, that's my ground clip and my positive clip. And I'm just going to double check that our short circuit is actually present where I'm expecting to see it as well. Yeah, no problem. All right. Power on. So we've got 2 amps going through. And all of the reflections ever. I'm just going to try and find angles where I'm not seeing reflections. A very reflective board this, so it's going to be hard to show you guys a good angle. Oh, we got something. I'm just going to turn that off a sec. Something just lit up like a Christmas tree up here. Get a better view of that. Yeah, so there's something warm back there that's heating up big time. I think it's on the other side of the board. Oh, is it one of these big boys? Oh yeah, there we go. Clear as day. It's one of those big bypass caps. And if I put on my macro lens, we can see that real close. So, which one is that? That's 1, 2, 3. Third one from the left. Nice deep short circuit there. Alright, so let's take a look at that bit that's failed under the microscope and see what exactly has happened there. So this dude here is our culprit. One of those big capacitors. Is there any visual signs of distress on it? Wow, those guys are thin. Yeah, nothing visually wrong. So what is this guy doing then? Let's pop back to the board view. So we're on the back of the motherboard, and it's this guy here, C7210, and that is PPBus HS CPU. So PPBus HS CPU, that's a high side CPU. This is directly connected to PPBus G3 Hot. PPBus G3 Hot, it goes through like a current sense resistor or something like that and becomes PPBus high side CPU. That basically is the main power input into the CPU power supply. So let's right click and search that, and that'll automatically find it in the schematic for me. And so if we have a look at here, where are we? vCore and System Agent. So we've got a big bulk bypass capacitor bank over here. And that's phase one of a two-phase power supply, and then we've got the System Agent power supply here that powers the I/O die and the I/O controller and stuff like that. Okay, and if we trace PPBus HS CPU back, we'll find that this becomes. We can trace this back from here. This will come back from a PPBus G3 Hot somewhere. Is it that guy? R5400. So PPBus G3 Hot is the input, and then HS CPU is the output, and these two lines here are current sense resistors going directly into this guy here, and this guy here is basically measuring the amount of power that the CPU is drawing. So this is power sense for the CPU. Cool. Okay, so where are we going to get another one of these from? What is it? It is 33 microfarad. Really? I thought it'd be higher than that. Oh, it is 16 volts though. Yeah. So this is a 33 microfarad 16 volt tantalum capacitor. So I'm going to need to find another one. I'm going to have a look at my donor boards and see if I've got anything. So let's pull out another party trick of Flex board view here. The question is, could I find this on any of my other boards? Well, what I can do is from Flex board view, I can go search, find a part, and I can tell it, here is my collection of Apple schematics. I'm looking for 33 microfarads at 16 volts. And I'll tell it to search. And now it's going to go through my collection of schematics and tell me any schematics I have that have 33 microfarad 16 volt capacitors in them. And so now I can have a look at this and go, 3476, I've got one of those. 3476, cool. Where is it in that then? So let's see. 3476. And pow. Looks like the same place, 33 microfarad, 16 volt polytantalum capacitor. And once again, this is probably, yeah, this is for CPU vCore on the 3476 as well. And is it going to highlight it on the board for me as well? No, but since we know what it's called, right, what did it say it was? That is C7371. That is on the back of the board. Let's have a look. There is our 33 microfarad 16 volt capacitor. Now it looks slightly different. Is it flat enough? That looks pretty flat to me. I think that's going to fit. As usual, I'm going to wet my joins here just because this is a big capacitor on a big power plane. So I'm just going to give myself a little bit of help before I hot air it off. I don't know how necessary this is, but every time I do it, it seems to go well. Okay, now comes the hot air. Whoops, the nozzle's not on. Oh, quick. There we go. Start warming up the board. Pick a pair of tweezers. Pick quickly. Ooh, that didn't sound very good. Something smells. Oh, my days, come on. Man, this guy doesn't want to go. I need some stronger tweezers. There we go. While I've got so much heat down, I'm just going to see if I can get another one off the board. Just so if that first one got cooked, we've got another one on hand. This thing is making some weird sounds. And man, this board smells. What is cooking? Probably the CPU on this poor board. Come on. God. That felt like a fight scene from the original Star Trek series. Da, 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 da. Let's test our donor capacitors on my transistor tester to see if they're in good condition. Alright, this doesn't have a very bright screen. However, we've got 33 microfarads at a decent ESR. So that one's good. Put that one to one side. What about the first one that I picked up? How do you feel? That was reading 42. Capacitors have got a really big margin of error on them. That seems a bit odd, that one. We use the second one that I took off the board just because that seems to be a lot closer to being in spec. Right, so we have a donor capacitor. Let's put that to one side. Now I've got to remove the dead one from this board. And because this is not a donor board, this is the customer's board, I'm a lot more scared of this one now. So let's see if I can do some prep to make this as easy as possible. I genuinely don't know if I should keep the heatsink on or not when doing this. I'm going to take the heatsink off just so we've got less things taking heat away from the board. But, you know, that might seem like an obvious thing, but if you keep the heatsink on, that's going to try and keep heat off of the core. But at the same time, it also means it's sinking heat away from the spot you're trying to heat up. So I actually don't know what the answer to that is. I don't know if it's better to remove the heatsink or not. As you see, I'm going to take it off anyway, just so I can try and get in and out and be quicker and just use less heat overall. Right, once again, I will wet the join. Flux. Right, it's coming for the burn. Here we go. There we go. Much less drama that time. Maybe because I was a little bit more prepared for a fight that time, I was able to move quicker. Now let's confirm the diagnosis. So with that capacitor removed, we should find that we're no longer shorted. So I'll just check the pads on both sides of this first. So I'll put my black probe on a screw hole, and we're going to check. Not sure which way is which. Okay, that looks like absolute ground because we've got like 0.1. And the other side. That's... Hang on a sec. I'm going to come off of this metal plate I'm sitting on. It seems to be a bit all over the place. Have we still got a lot of heat here? It's cooling down. Having the board be hot can give you misleading readings. Let's try that again. Now I'm not sitting on my hot plate. Okay, there we go. Yeah, now we've got kiloohms and rising. Yeah, where I was sitting on a metal plate, I probably had a short somewhere else there. Unwittingly, as it were. Good. Okay. So, now we've just got to put a new... now we've just got to put our donor capacitor on there. So, let's tidy up those pads. Right, put some more flux on those. And I'm going to wick them down just to remove the old solder. And we should be able to do all of this with just a soldering iron now, because it's just a big capacitor. And I would like to avoid using hot air because we're on the back of the CPU here. It's just not a place where you want a lot of heat to be. Right, so the lower point is our ground plane. So I'm going to put a touch of fresh solder onto that pad, and we can get our donor capacitor on. A little bit of flux and some nice fresh leaded solder. Forbidden incense. I've done quite a couple of soldering videos recently, and there's been some people in the comments like sort of, oh, don't inhale the fumes and stuff. So first of all, just to address that, I'm aware that I should have an extractor. It's on my radar. But just so you guys do know, when I'm soldering like this, I'm not inhaling the fumes. I actually hold my breath while I solder, and then when the fumes clear, I then exhale and go and blow the fumes away kind of thing. I know that's not a substitute for an extractor, but I'm not sitting here huffing the fumes, don't worry. Right. Let's flow that guy on. Lovely. Some more flux on the other side. I'll tell you one thing though, Amtech's flux smells really good. I don't sniff it, but obviously it's in the air, you can't help it. Alright, there we go. When I used to have knockoff Amtech's flux that was fake, it smelled horrible, which was a good incentive not to smell it. But the real stuff that I've got at the moment, I've got Amtech's, it's the V3 one, the one that's actually legal in the UK. I hate to say it, but it smells really nice. I would love someone to make an Amtech's candle that isn't poisonous. Right, I just had a little train of customers come in, and so I'm just going to... I've just put my hot air on 100 degrees, and I'm just gently warming up the board again, just so that flux just goes liquid, and that'll just make it easier to clean up, because flux does go horrible and sticky residue when it dries out. So we do want to clean that. I do need a bit more than that. Let's go to 200. I'm not trying to reflow the board, I just want to warm the board up a little bit. There we go. That should do it. There we go. And just to confirm... Oh boy. What happened? What happened? Oh, heck. Damn it. Alright, I'll reflow it. The problem with this board is that the height of these capacitors is the maximum Z height for the bottom of the board. The board won't go back in the laptop properly if it's sticking up like that. Sag. Guess I'll smother it in flux again. Blah. Alright, come on. Let's go for a speedy reflow now. We want to bring this up to temperature, get it to sit flat, get out. There we go. I think I'm having a much easier time reflowing this one because that heatsink isn't there. I think when I was trying to remove the donor capacitors from the donor board, I think I was losing a lot more heat than I thought just through the board, through the CPU, and through the heatsink. Which kind of makes sense because that's what the heatsink is supposed to do, you know? There we go, that's better. That's actually flat now. Good. Let's reassemble. Okay, this video is long enough already, so I'm going to clean up this thermal paste. I'm going to, there's a bit of flux on the board there I'm going to clean up. I'm going to remove my jumper wires and put it all back in the laptop. So I'm just going to speed through that at top speed, and we'll see if we're WinRAR. I always forget to put on these stupid air guides before everything is screwed into place. It's possible to do it after the fact, but it's a pain in the ass, so I'm now going to pause. It ain't pretty, but it'll do. That little rubber bit is just there to stop hot air from just recycling back into the fan again. Okay. Loose fit. I may as well put all the screws in at this point. I've committed this far. Okay, right. Power supply. Let's see. Power on. 20 volts. I'm opening the lid. That's a chime. Love to see it. And we should see the current start climbing as it starts to charge. Oh, apparently the battery is full. That's fun. Battery is reading 98%. So yeah, I thought the battery would have gone flat because I thought the battery supply I thought the battery supply fed straight into PP-Bus G3 Hot, but clearly this particular motherboard, it has a mechanism to switch off the battery in a fault condition in the same way that it can switch off the Type-C in a fault condition. Cool. All right, so fairly uncommon fault in my opinion there. Other people who work on MacBooks all the time might go, oh yeah, those fail now and then or something like that, but I've not seen a big tantalum capacitor like that fail for a long time. They were always nicknamed tantrum capacitors because they were notorious for failure. But in my experience, modern tantalums, they seem to have become a lot more reliable, I think. I certainly feel like I see them fail significantly less often. So I'm going to stick the screws back in this. However, past that, we are fundamentally done. So thank you very much for watching, everyone. Thank you, as always, to my patrons and my channel subscribers and my Twitch subscribers as well. And I will see you guys in the next video. Bye for now. That is one fixed laptop. So, could the screaming children outside the shop please walk on by? All right. So, are you guys done? Bloody children. Ugh, get off my lawn. Ugh.